but it doesn't, I mean, you can think about it, no problem, and you can write it down in a computer, no problem. You don't want to list all the elements in a computer. That doesn't, you can't do that. But you can list particular elements. Although even that actually may exhaust the memory of my computer to write down certain elements in here. Yeah, I probably don't want to write down a vector with 10 million elements in the that's a good question. These are dense. You can, however, create, just like with matrices, you can make a sparse vector space where the elements have a sparse representation. And to do that, you say sparse equals true. So if I do that, I get the vector space, sparse vector space. So as an abstract mathematical object, this is exactly the same as the other one. But in the computer, the underlying representation of the vectors is different. And here I should be able to make a vector. I'm kind of scared that I'm going to crash and destroy my entire lecture, but okay, I made the 0 vector, good. I really don't want to print it out, but I'll print its first element. There it is. And we could set an element equal to something. 20. What am I going to see when I press return right here? Tom? 3, yes. Because this 20 gets, whoa, what the? Oh no. Bug. Huh, interesting. Let's try this equals 3. False. What the heck? That's disturbing. Integer. Huh.
Did you forget the fields somehow?
No, I think that it didn't cast on assignment. Yeah. Interesting.
Well, ask for parent of W0.
Like, generic sparse. It doesn't do any coercion on assignment. Huh. That's interesting. So, I run. Oh, I can't get access to that source code. All right, so you want to know where the saved source code is. That was one person's request. So let's see. I want to look and actually see this bug. So the actual code, if you find any copy of Sage and then extract it, sorry, let me make this huge so you can see exactly what I'm doing. This is true for a binary or the source code of Sage. If you extract it, the directory you get will look something like this. There'll be a few less files. There are a couple of extra files for me because this is my own personal copy and I've added various things there. But inside there's a subdirectory named devel. Devel for developer, because I mean that's where developers look, in the devel subdirectory. If you look in there, there are a couple of different code branches. And the one you want to look in is called Sage. That has all the top-level Sage library code that we've written. And if you look inside of there, there's various files like a README file and various things related to redistributing this with Sage. And inside there, there's a subdirectory that has the actual Sage library code. This is where the real exciting stuff is. Here you have subdirectories for code related to algebra, calculus, combinatorics, and modules. By the way, a module, if I get to it, which I will easily do today, modules are exactly like vector spaces. The only difference in the axiom is that instead of requiring that the K be a field, we just allow it to be a ring. That's it. That's the only difference. So when people talk about modules, it's exactly like vector spaces, except the K is a ring instead of a field. The difference is that fields are way more user-friendly than modules, as it turns out, because with vector space, I just said fields, but I meant to say vector spaces. Vector spaces are far more user-friendly than modules. With vector spaces, there are a whole bunch of theorems that just make everything really easy to do. Theorems are easy to prove, calculations are easy, things are just easy. When you replace the field by an arbitrary ring, things get vastly more complicated. So module theory is way harder than theory of vector spaces. But the definition isn't much harder. It's actually easier. You just don't require that every element be invertible in the ring and the scalars. You don't require every scalar is invertible. Okay, so let's look inside here in the modules directory. And there we find all the code that implements vectors and vector spaces and modules and so on. And the data type of our buggy free module element it's something that's defined in the file free module element. So that's where I want to look. Okay? So now I look at that file, free module element. And I get a bunch of code. In fact, this file is over almost 2,000 lines long. And in there, everything about, well, not everything, but a lot of things about this particular class will be located. So, so we want to figure out why in the heck, what's going on right here. What code gets executed when that happens? Okay? That's what we're curious about. So, one thing, if you know Python very well, you'll know that the set item method is what gets called when you do some object square brackets equals something else. There's a special method in Python, just like the representation method or something else, called set item. So it actually has, maybe set, yeah, I think it's set item, set something. Yeah, set item. And that's what gets called. If you didn't know that, you might be able to trace execution of that assignment and see what's going on if you're using the command line. But since I happen to know that, I'll just go directly and find, just by searching in the file, set item. And now I think there's an implementation of sparse and dense vectors, and I don't know which one this is. So what I have to do is look higher in the file to see what class this is. This is generic dense. So I need to look farther. Here's the generic sparse class. So all the code related to sparse vectors will be defined in this class, and some additional code that is generic, that isn't just for sparse vectors, can be defined in the free module element class. So you have this hierarchy. That's the way the code's laid out. It's an object-oriented system, and so you have general free module elements, where things are implemented that make sense for all free module elements. And then deriving from that, you have special code that pertains just to sparse free module elements. So an example of something that you could implement up here is dot product. Doesn't depend on whether things sparse or dense. There's existing implementation that you could write that would make sense for either sparse or dense or anything else. However, of course, you'd really want to make a better implementation of dot product down here, because if you have two sparse vectors, you can do the dot product more quickly by just considering the non-zero, the kind of intersection of the set of positions where each one has non-zero entries. So that's how the code's laid out. And let's just scroll down until you find this buggy call method, which, set item method. So going down. Get item. Let's try set item. Here it is, set item. So, look at that. Set item. Here's the implementation. It takes as input the position that should be set and the value it should be set to. It checks to make sure that you didn't make sure that the position, that you're not trying to say vector square brackets Fred equals something. You have to give it an integer, or something that makes sense as an integer, as the index. Then it checks that you haven't tried to address a position that's out of bounds. So if your vector is a vector with 100 different entries, you can't do square brackets 200. And then finally, it just sets the value by calling the set function. Now let's look at the set function. And the set function does absolutely no type checking at all. It just sets the ith entry equal to the given value. Or if you're trying to set equal to 0, it deletes that entry. So the bug is that right here, a coercion should be performed. Yes?
I think the coercion should be performed in the set item.
How, are you sure? Because it is sets a Python method, so I'm worried which you should do. And it's not set unsafe or something, though.
It says in documentation.
With no type or bounds checking. Okay, given that documentation, it's definitely fair to put the coercion in set item. I agree with you. And by the way, what would have happened, this is like the whole referee process in 1 second in front of you. What would have happened is I would have put the set right here, having not even looked at the documentation. Then I would have posted a patch doing that on the website and said, hey, Robert, referee this. He would have looked at it and said, that's just stupid. Look, right in the documentation it says there's no type checking. And then it would have been rejected. So you just saw a live rejection of the thesis advisor's patch by Stein. So I will fix this. So we have to figure out what to coerce the value into. And I mean, in the case that we were looking at before, it was GF17. But in general, we have to figure out what we're supposed to put there. And we need to do the coercion of value into something. So what will we do it into? Well, we have to figure out what the base ring of the parent of this vector is. And then you just go hunting and figure out what the vector knows about itself efficiently. So what sort of stuff does it know about itself? It knows its parent. So these are the attributes of the vector. It has a parent, it has entries, it has the number of entries possible. So, and the parent has a base ring. So what we'll do is we'll say self is, when you write object-oriented code in Python, inside of each class, self is the variable that refers to that particular class. It's called this, I think, in C++. And maybe in Java?
In Java, yeah.
It's just like this in Java or C++. One thing, in C++, you don't have to explicitly refer to this. It's just implicit in the scope of the function definition. In Python, it's not explicit, because in Python, implicit's better than explicit. So self-parent.base ring value. Okay. So now when I do that, it will turn value into the right sort of thing and then set it. Okay? Any problems with that? E is going to referee this patch.
Well, for completeness, should you write a doc test?
Yeah.
Actually test it.
But I should test it first. But you're right. This would not be enough to satisfy E, the next referee. He would want you to put an example that illustrates that this really does happen, that sort of thing. That we really did add an extra check-in. So after fixing this, I will exit out of Sage, the editor, and then if you type Sage space -b, it will rebuild any changes that you've made. So it'll take all the changes you made to the Sage library and make them part of your current running copy of Sage.
So
You
that's
still have to
happening on your machine right now.
Yes, this is all happening on my machine. If you wanted to do what I'm doing, you have to have Sage installed on your own computer. At one point, we had some grand plans to make it so that you could easily do development just like this, all via a web browser on some central server. But then Tom got distracted with other things. But Tom had some grand plans like that, which would be pretty cool. I mean, you could imagine somehow setting it up so that you just log into some web app and literally do development just like I did and see the changes and then etc. It's possible. It would be an extremely interesting project to try. Just like Wikipedia, you can change pages in Wikipedia right there on their website. It's kind of the whole point. Why not make it so people can develop on Sage right there through a web interface? And you might be able to increase the number of developers.
Might just be broken all the time.
Well, the thing is they each have their own little branch. So the only thing that would be broken would be their code. Okay, so now let's just try it out, see what happened. So we're going to make this vector space over GF17, very large dimension, sparse equals true. And then we're going to make a vector in there, the 0 vector. And then we're going to set some entry equal to 20. And now, the moment of truth, 3. Yay. Nice. Yay. And it really is an element of the finite field. And then the other check we can do is that if we try to set equal to something that doesn't coerce into GF17, what's an example of something that just doesn't make any sense as an element of GF17? Just think of something.
Float.
What? Foo. Okay.
A float.
A float? Right, I'll try a float. Root 2. Okay. I'll try that. That sounds pretty ready. Please go boom. Please go, boom. So the reason there's a big pause is it's starting at one copy of maxima, where it evaluates square root of 2 symbolically. So if I did the same thing again, it would be fast, as you can see. But the very initial startup can be slow. By the way, that's not the long-term plan for Sage, that you always have to use maxima to do symbolic manipulation. There is one of the projects which will be part of Jim's RU this summer and also funded by Google is rewriting all of the symbolic stuff in Sage so it doesn't use maxima for the basic arithmetic. And this guy, Gary Furnish, is working on this. So this is great. So we got an error just like we wanted. And we also got some examples that illustrate really everything. So I'm going to take these examples and paste them into the documentation that I had before. So that E will be happy with the patch. So, oops. So, is it here? Yeah, okay. Wait, is it here? Actually, I think this is the wrong one. Here's the right one. Notice incidentally that the one for dense vectors is right. It's the one for sparse vectors that's wrong. Okay, so now we put the code in. You obviously don't want to have that massive traceback sitting there in the examples, because if you type something question mark and saw that huge traceback, you would be very unhappy. And your patch will surely be rejected. There's a certain format that these are supposed to be formatted in, and I've just done it. And you can omit arbitrary stuff in the doc streams with 3 dots. And in Emacs, there's a keystroke that indents everything in one fell swoop. Same in the notebook. By the way, if you have a bunch of code in the notebook and you highlight it and then hit the tab key, it'll move over 4 spaces. And if you hit Shift Tab, it'll move back 4 spaces. Okay, so now we have our examples. And everything's always listed examples. Set the ith entry of sum to value. And so this is much nicer, and there you are. So now let's try it out, see if this is really right. So if you have a file in the Sage library and you say sage-t, and then give the file name, it will take every single example in that file, extract it from the file, run it, and make sure it works as claimed. And the fact that it said all tests pass means it worked as claimed. If you want to see what happens when you screw up, I'll show you. So set item. Set item. Here it is. So let's say I change this back to 20. Okay. Now we'll see what happens. So it better not be the case that every test passes. If every test passes, then there's something very wrong. And here's what it does. It shows you which test failed, what you said you were supposed to get as the output from the test, and what Sage really produced. So, and we run, there are like over 50,000 lines of input like this that get run on a regular basis. So let me fix that. Okay, put it back to unit 3. Oops. Okay, and now I'm almost done. By the way, the code that we're working with there, it wasn't Python code, it was Cython code. But you barely had to notice. In fact, the code we added was exactly the same if it had been Python code. You didn't have to worry about the fact that a C compiler is being used behind the scenes. It just sort of works. You don't have to worry about the fact it was Cython C code instead of Python code. It looked almost the same. If you change a .py file which contains Python code in the Sage library, then you do exactly the same thing. You type sage-b to copy that code into the right place and then run it. So the development workflow is identical with Python and Cython code when you're working on Sage itself. You can see it still works. Oops. Oops, 20. Okay, so it still works, and everything's good. And if you type, there's a revision control system that Sage uses called Mercurial, which I wrote down right here. It's included, it's written almost entirely in Python. It's included with every single copy of Sage, both source or binary. And you can use it from within the Sage interpreter. You can also use it directly on the command line. It has a nice command line interface. Or you can just say HG, the chemical symbol for mercurial, _ Sage. That gives you the mercurial repository. And then there are a whole bunch of commands that you can see right here. One of them, diff, will tell you what you've changed when you've done development. So if I do hg_sage.diff, it shows me exactly what I've changed. And notice what I've changed is I added a whole bunch of lines. This is just a standard unified diff that the diff-u command would output. And I also deleted this line, self.setIValue, and replaced it by this other line. Okay? So I see that. And now if I want to check in my changes, I just do hg_sage.ci for check-in. That checks in the changes. This does not use the internet at all. It doesn't contact any other website or any other repository. I don't need CVS or SVN commit privileges or anything. This is being checked in entirely right here on my laptop. So fix a bug in setting entries of a free module element, a sparse free module element. So I described what I did, I saved the result, and now there's another command, export. Well, if I do hg_sage.log, it'll show the log of all the changes that are in the repository. There are 9,609 change sets. I can look at the contents of any change set. I can see exactly what's in there. In fact, you can nicely browse all the change sets by just saying hg_sage.browse. You just type that one thing. It starts a web server, just like the Sage Notebook starts a web server, pops up your web browser viewing a certain local web page that allows you to browse through all of the change sets that have ever occurred in the history of Sage, well, at least in the last 3.5 years or so. So here is the change set I just made. You get a nice colorful diff. You can also look at the file itself that I changed. And that's kind of fun because you can do, for example, annotate, and it will show you who changed last each line. So if you want to find out who's responsible for the bug you just fixed, you can always do that. So let's see. I guess it was, this was it. This was the line. This was the thing that we fixed right here. So, well, you can see that I'm responsible for everything in the neighborhood of this problem. So definitely my fault. You can also see kind of who's touched a given file. If you click revisions on a given file, when you're looking at a given file, it says that this was the last thing that changed. The previous thing was Jason Grout, who did something, he added something involving 3D arrows or 3D plotting, which in fact was relevant to all those little arrows I drew. And you can see that John Cremona did something here. And in each case, you can click on like on annotate, and it'll show you the file as it was when he changed it as a result of his patch. So in fact, here, see, this is what it was like. No, sorry. Here's what it was like before we changed it. Here was the change set where this particular code was written. And this will show, this shows the moving free module element code into Pyrex. So rewriting Python code into Pyrex, something I did in 2006, was when that bug was, well, maybe not first introduced, but that was when it was checked into the repository in that file. Okay, so that's what you can do by doing hg_sage browse. Every single copy of Sage, both source or binary, has the complete revision history of all the Sage source code included in it, which you can just browse at your leisure with a web browser right on your computer. Okay, finally, if I say export, well, if you look at the log, see the change set number 9609, and do hg_sage.export 9609, you get a file in the current directory called 9609.patch. It's a plain text file, and you can then post that file somewhere or email it, and then a person can apply that, and they get the change, they get the fix. So I will post that to the Sage bug tracker. So I go to the Sage bug tracker, I write bug in setting elements of sparse vectors. Referees are standing by, right?
Oh, there's already a track on that.
There is? Oh, you made a track ticket.
3025.
Oh, the first thing you should do before you make a new track ticket, which I stupidly didn't think to do, is search to see whether somebody else has already made a similar track ticket. And there's a plain text search in the upper right. So you can see right here, sparse vectors don't pass on assignment. So Tom Boothby in the back already made that change, or already put an example showing that there was a bug. He hasn't fixed it yet, so I attach my fix, which is in my patches directory. This fixes the bug. Okay, I add the attachment, and then I go back and I say that, in fact, I fixed it, it has a patch, and it needs to be reviewed. And then I submit that change. Oh, you didn't set a milestone. Okay, so now there's a patch up, it needs review. Reviewers are standing by, we'll see if in the next 5 minutes it gets a positive or negative review. Usually patches get negative reviews first and then they eventually get a positive review. Alright, so moving on. By the way, within the notebook, okay, yeah. So what do you think is going to happen in the notebook if what do you think it's going to output right now if I hit Shift Enter? So I'm going to put 20 or 3. What's your guess? I didn't click anything at the top of the screen. All I did, I went up there for a second, I changed my mind, I haven't changed anything. All I did was reevaluate a couple of cells, nothing else in this one. I mean, you might as well guess, because there's no a priori way you would know unless you already knew. What would you like it to do, actually? That's a better question. Would you rather it gives you 3 or 20 at this point? Vote, raise your hand right now if you'd rather it gives you 3. Okay, raise your hand if you'd rather it give you 20. Okay, well, the minority is what happens. It does give you 20. The copy of Sage that's running here, even though it's on the same computer and everything, when you change by doing some work elsewhere on the same computer, it doesn't restart this one, and it doesn't change the state of how the code works in here. It's using the old code from before you made any changes. Some other systems are different. For example, in Magma, it would literally have changed that right when it was running, which is really nice in some ways, but kind of scary if you think about it. So what you have to do, if you wanted to start using the new code, is you go to the top, and you click on Action, Restart Worksheet. Now once you do that, it will use the new code, as we shall see. Here we are. Or not. That doesn't make sense. It has to use the new code. Maybe I didn't really click. Restart. Okay, there's red on the side, so it definitely got restarted. Okay, before I guess I didn't quite click. I only thought I did. By the way, a cell has a little red line just to the left of it if it hasn't been evaluated in that session. So because there's a little red line there, I know that I really restarted. So it's right when you restart, it puts little red lines on the left. So now it's changed. I haven't obviously lost anything I typed in, but it's a new running copy of Sage. When you click restart, what it does is it kills the one copy of Sage that was running and starts up another one, and then starts using that one instead. Okay, so here's another thing. There's a very nice shorthand for making vector space of dimension something got by all these tuples over a given base field. You just say base field to the power of the dimension. Just like you write Rn, you can put cc to the 3 or qq to the 2. So this is completely equivalent to typing free module qq, comma 2. So it's actually a very, very handy shorthand.
How do you use that since you have to set v equal to cc3? What good does it do you to type cc3?
Nothing, because it's not printing anything out. What good does it do me? It does me no good at all. The only thing is it prints something out. It's kind of useless. It would be much better to do that, because now I can do something with it. So yes, it does me no good. Just throwing it is like a waste of energy. Okay, so we're doing nothing interesting about it, just like you said, literally, bold, so it's nothing interesting. Okay, so now a little bit more. So now you know every step needed to be a Sage developer. By the way, after you submit the patch, you sit there and refresh, hoping somebody's going to referee your patch. Nobody has. And then you maybe you start emailing people and saying, please referee my patch. You owe me one because I refereed your patch last week, etc., etc. But don't do that too much because you could get really annoying. Okay, here's an example where we make a subspace of a vector space. So things are starting to get interesting. So we make a vector space, and then we make a subspace. It puts the subspace in echelon form by default. However, if you say span of basis, then it won't put it in echelon form. It'll leave it in the form that you want, which is nice. So you can make subspaces. Let's see. Here's an example of, I guess, just plotting this vector space and then a vector that's on the subspace and a vector that isn't in the subspace. Another way to make a vector space is to compute the kernel of a matrix. If you make a matrix in some way and it's over a field and ask for its kernel, the output is a vector space. So that's another way of making a vector space in Sage. You can also, if you make a couple of subspaces, you can intersect them. So graphically, here's two subspaces, or like pieces of the two subspaces. And then if you say one subspace dot intersection the other one, it computes the intersection of the two subspaces. And if you want to know what algorithm it uses, if you just put double question mark here and hit the tab key, you'll see the source code. And the source code contains a description of the algorithm. Okay, so I'll pick up on Monday with combinatorics, part 1. There's a little bit more to the linear algebra worksheet and demo here, so I strongly encourage you to download it from the Sage Math 480 website and read the rest, okay? And then be